To get started, I'm Doug Wenninger, CEO of Alliance. I won't introduce all of the people in black shirts, but there's a bunch of Alliance staff dedicated to making this afternoon go right. I want to thank everybody for coming. I know you have to make travel arrangements to get here. It's a disruption to your normal schedules. I hope it's not too much of a disruption. I hope we can have some fun. I hope you learned something that you didn't know before. We want to tell you about us and the technology that we have for your industry and for the industries that you serve. So, kind of the lay of the land, the way this afternoon will go. We've got a presentation. I will try very hard not to bore you too much. If I see you starting to go to sleep, maybe we'll end early and start the tour early. At the end of it, we've got a panel discussion with a few folks that are here visiting. And when we're done with the presentation, we'll gather up here, we'll divide into tour groups of about 10 people. Alliance employees will lead you on the tour. That total tour time will take about 1 hour and 15 minutes. Once that's done, feel free to roam. Our building is your playground for the day. And we want you to see everything you came to see, and I want you to dream a little bit. Put on your vision cap for this afternoon and think about your operations, think about possibilities of things that maybe could be done. We want you to dream a little bit. Our ideas on what we want to develop, what we need to develop, come from you, our customer base. So we want your input. So I'll start with a little brief introduction about who we are and what we do. What does Alliance Automation do? We innovate, we automate, we deliver manufacturing solutions. We design and build custom automation systems to help manufacturers with various problems. An example would be improved quality. An anecdotal example I like to give. In 2011, General Motors' #1 warranty claim was an oil seal that was leaking on the drive shaft of their GM pickup trucks. 7% of the drive shafts put out in the field needed to be repaired at an average repair cost of about $900. 7% of their total trucks times 900, it's a staggering number, do the math. And they came to us to design a machine to change the way that oil seal was assembled, and we took their 7% scrap rate down to 0.02% scrap. That's an example of how we improve quality issues. Another one is promote a safe work environment. There's jobs that human beings just weren't intended to do. Think hot, dirty foundry work, or think dismantling a pallet. Increase productivity, that one's obvious. Every manufacturer that ever existed would like to increase productivity. Reduce costs, another obvious one. Nobody wants your costs to go up. Everybody wants their bottom line to grow. And what's the #1 reason that we help manufacturers in today's world? Who's got an answer? Workforce. Can't find people. It's an epidemic. I shared with the group that was here this morning. A couple weeks ago, I was at a Honda plant here in Ohio. They've got a very large manufacturing presence in Ohio. The particular plant I was visiting has 950 employees. We always ask, how many employees are you short today? The answer was 300. And that's at Honda, whose environment is pristine, you can eat off the floor. Those are sought after jobs. More difficult, a little more difficult in the pallet industry. Our geographic market is all of North America. Wherever you see the red dot, we have an installed base of equipment. The United States, Canada, and Mexico, and we are currently working on expanding into Europe. More on that a little bit later. You're sitting in this building. We've got about approximately 200 people that work out of this location. We moved in here a year ago, consolidated 4 different buildings into one. We are divided into 3 separate business units. One of them is palletizing and logistics. It's not the pallet industry, but it's everybody that uses your product. Second one is engineered systems. And that's a very broad category, but think automotive. You walk over in this section of the building later on the tour, you'll see a machine that's building parts for Tesla. You'll see a machine that's building parts for Ram truck and various other applications. And the pallet industry. And we have our standard offerings of the robotic pallet dismantler, which most of you have probably seen in some form or fashion, the urban sawmill, the Badger Sawmill Series, and the sort and repair lines that we build. There's information in the black bags that you were given. There's a booklet that we printed out that has specs on all of this stuff if you want to learn more, and you'll see it running today. Not going to spend much time talking about it here. One thing that I like to tell people, we are not just a pallet equipment manufacturer. We're a manufacturing solutions provider. Why is that relevant to the pallet industry? I think it's very relevant because we're always in other industries. We're working for your customers. We're seeing the problems that they have. We're solving their problems. And we're bringing pieces of technology from other industries to help improve the pallet industry. A brief video, I'll keep this very short, of just a collage of things that we do. Lighting and electronics assembly is a very big market for us. There's machines on our floor that are serving that market. A motor housing gauge for an aluminum foundry. Automotive headliners. At last count, we've assembled the headline. We've built the equipment to assemble the headliners in about 50 different vehicles out on the road today. The robotic pallet dismantler, which you can see in action later this afternoon. We could go on and on all afternoon watching videos. That's not what you came for. Talk a little bit about our history. The company was founded in 2008 in Delphus, Ohio, which is about 20 minutes east of here. Why Delphus? We were young and had no money, and we found a machine or a building that was really cheap. Our first customer was this little pallet company called CHEP. It started with me reaching out to electrical vendors, various vendors, Yaskawa. I'll talk more about you in a minute. We're hanging our shingle out. Can you help us get started? And they brought us this opportunity to build a control panel. It was CHEP, and that led to, can you do programming, and can you do conveyors, and can you do this and that? And today we're CHEP's largest equipment supplier in North America. We outgrew that location, moved to Van Wert in 2010, a year and a half later, kept the original building and worked out of both. In 2014, you see the higher end automotive type applications we're doing. That was half of our business, and then we were doing CHEP. And that's all I knew about the pallet industry was CHEP. Most people don't realize that your industry is a massive industry that serves everybody that buys anything. Pallets move the world. Roger, stand up. Roger Christian from Yaskawa Motoman Robotics. Came to me in 2014 and he said, we see all the pallet work you're doing and we know that you know our robots. We think there's an opportunity for a bigger market. And we started exploring the market together. They had done a market study of studying automation trends in Europe. And they came to me and presented how there are industries in Europe that are way more advanced in automation than they are in the United States. That's a ripe opportunity. And one of them was lumber and pallets. So I went to my first NWPCA annual leadership conference in 2014 with a tiny little booth, not having a clue what I was doing, and used robot video to try to attract people to stop and talk. Well, they did. Everybody was interested and kind of scared and nervous about, you can't use robots in a pallet plant. Well, we thought we could. So I started asking people if you could solve anything, what's the number one thing in your pallet plant that if you could solve it, what would it be? And I probably heard 200 times over the course of 2 days, if you could dismantle a pallet with a robot, that's like the holy grail for us. So we started down that journey. So in 2014, we started dedicating a portion of our annual profits to R&D. And today we always have R&D projects in queue. Our goal is to have two new R&D projects active at all times, developing the next best thing for your industry, for your needs, to solve your problems. In 2015, our automotive install base demanded service in Mexico. So we developed a partnership with a company in Mexico. They service our stuff down there. From time to time, they build equipment for us. And we have the same labor problems that all of you have. And we have a very large Mexican workforce presence. We bring people up on work visas, and all of them are degreed engineers. And we would never have grown to the size that we are without that Mexico connection. They're very valuable to us. Moving on, 2017, we worked on it for 3 years. We installed the first robotic pallet dismantler. Thank you, McVantage. I don't know if Rick Anderson is still here. He spent a lot of time in Van Wert, Ohio, helping us perfect that machine. All of the lumber coming off the back end of that machine led to the need for the urban sawmill. And we worked on a joint venture with Camps to develop that machine. Both of those you'll see running today. To further advance us into the pallet industry, we had an opportunity to acquire Smetco in summer of 2020. They had been around since 1966. Any of you from the pallet industry have probably seen their equipment or have it in your facilities. But it further spurred us into whitewood sort and repair. 2021, we consolidated 4 facilities. We started construction to build this facility, to consolidate 4 buildings here. Moved in 2022. Which brings us up to current. 2023 has been a tough year, I think, for all of us with the economy shifting, but it's been a really busy year for us. Might seem insignificant, but we've developed our own line of conveyors. Who cares, right? It's just a conveyor. Well, when the supply chain woes of 2020 and 2021 hit, our average lead time for purchased conveyors went from 6 or 8 weeks to 38 to 50 weeks, and then that might not be true either. And our friends at Amazon bought up the capacity of everybody. And trust me, we played second fiddle to Amazon. So did everybody else. So we said, this doesn't work. We've got to design and build our own. So we did that. And earlier this year, we started using them large scale on all of our projects. If you see roller conveyors in this building, it's our product. Why is it significant to you? For about the same price that you can buy everybody else's. Ours are easier to work on. They're much heavier duty. Trust me, they will last longer. And you'll be able to take a good hard look at those today. If some of you are maintenance staff, pay attention to it. We came out with the Badger Sawmill Series. Feedback from the industry. They loved the urban sawmill, but for some plants it was just too big. It's a 150-foot long machine. You can't fit it. And it's a big price tag. And some of you don't need to process that much lumber. So we came out with a smaller version, about half the length, about half the price, and between 2/3 and 3/4 of the production. but gives you all the same capabilities on board measurement and board trimming and board optimization that you get with the urban sawmill. You can buy two, you get more production for about the same price. Vision Nav Robotics, an area that, to my knowledge, I don't know if any of you in the pallet industry have automated as your forklift traffic. But we think it's a big frontier that a lot of other industries are already using. We want to bring this technology to the pallet industry. You'll see Vision Nav equipment running here today. Sycamon is based out of the Netherlands. They've been around since I think the early 1980s. They have a very large presence of equipment in the pallet industry in Europe. We started searching for a European partner because there's demand for our products in Europe, and we didn't feel like we were a mature enough company to be here in Ohio servicing stuff across the pond. We needed a partner. They're here today. They're demonstrating some of their stuff, a very small sampling of their stuff that they offer. And it's a two-way street. They've got some technology that we don't, that we can bring to the States, and they're representing us as our sales and service arm in Europe. And the other partnership starting this year is Ivasys, also, well, based out of Sweden. As we looked at the journey of automating a pallet recycling facility, we started with, what do you want? Well, you wanted to dismantle it. Then we had to process all the lumber coming off of that dismantling. What's the next frontier for us? Well, if we're going to automate the pallet repair process, it starts with knowing what you're getting. It starts with the inspection. So 5-6 years ago, we started working on pallet inspection technology using Vision. I mentioned earlier, CHEP is our largest customer. We've installed a lot of Vision inspection systems in their plants. But their technology isn't suited for the rest of the industry. We say pallets are like snowflakes, there's no two alike. A CHEP pallet design is very standard. It's a lot easier to inspect. So we started down that journey, fell into many holes in the ground, many pitfalls, and long story short, ended up finding Ivasys, and we have a partnership with them. They are very good on the vision and AI technology, way better than our solution was, and I'm not ashamed to say that. That's what their specialty is. And they were also looking for a partner to help them expand in North America, somebody that understands machine build, conveyance, all the things that go into using their system. So that's a partnership that we would like to highlight today. You will see their machine running on a pallet repair line that will be installed in a couple months at Niagara Pallet. Stefan, would you join me? Stefan Bowman is the CEO of Ivasys.
And I'm from Sweden. That's the most exciting thing that happened to the waitress at the beer barrel yesterday. She was so excited. Like, oh my gosh, are you really from Sweden? No. So it's really exciting. You should come. You've been there, it was nice. Now, not so nice. Very cold now. But yeah, so Ivasys is a company focusing on visual inspection only. Been around for 20 years. And we did a lot of machine vision for easy applications. Let's say fuel injectors, or the customer was furious, so we had to basically go back and redo everything. But Ivasys has been working with a pallet inspection only for the last 5 years, I would say. So we are, see if you can do it. Yeah. So we are approximately 40 employees based out of Stockholm. And then this is what we do. So just to get this pallet inspection setup working, it was a lot of manpower. And then we got a lot of requests from the US. Yeah, we also need to check this. And back to my original statement, how hard can that be? And that was even worse because the US pallets are less standardized than the European pallets. So it was the whole journey back all over again. So, I would say in the US, pallets frequently break inside the machine, which is 3 feet long. Doesn't really happen in Europe. But we have other equipment as well, like for the dental implant industry or fuel injectors. We have some at Scania, motor assembly, but we basically started all that and focused only on the pallets. Because that's hard enough. So then we actually started out using this old school vision setup, and it didn't work at all. Because if you remember what I said about the object being fixed, the pallets vary in height. And I think I spoke with Harry Mills. I said, yeah, so a stack of 20 PLAs, so 20 shafts should be, I don't know, this high. I said, no, it's this high. I'm like, but the spec said 6.5 inches. And they were, I don't know, 5 inches. And if you didn't configure the system, it would just fail miserably. So we had to abandon the entire setup with vision equipment and go AI. So 5 years ago, this wouldn't have been possible because we had to use these neural networks. And I also can make a reference to Tesla because when you drive a Tesla and it finds the road markings in the road, that's a neural network finding these. And then the more it sees, the more it extrapolates and then says, yeah, this is also road marking. It's basically what this machine does as well for all the different components. But it's been really, really hard. But it's working great as of now. And what it's great about it, it's an AI system. So let's say we currently check 86 different parameters on this machine. And then Fred, he really wants to check for, I don't know, flower markings on the blocks. We could do that as well. So we could add that, because if we can see it, then the visual machine can see it. And it needs to see some of it and train, and then it will become more and more robust, and then it will be as great as any of you.
So if I can interrupt for just a second. When we were trying to design our own system, we were using very different technology than what Ibisys is, and it was, I will say, more old school vision technology. And we were never going to get to where they're at using the technology we were using. So when we started saying, okay, this isn't going to work, we need a partner, we need to solve this problem, I looked at a whole bunch of different companies doing the same thing, and their technology is beyond anything else that we could find. And we mentioned he's been at it for 20 years and specifically the pallets for 5 years. It's a long road to get from where they're at to where we need to go. The other thing, they're using AI, we were not. And I can't say that I fully understand what that even means, but what I do know is it gives the machine the ability to see a pallet the way you or I would. They're all different, and our eyes are constantly scanning, and we see boards, and we see nails, and we see a crack, and we see a nail sticking up, and we see a board that's broken or a board that's missing, and our brains can process that very quickly. Their machine sees it just like that, and it recognizes patterns. So if it sees something new that it hasn't seen before, it knows I need to start looking for that. I'll let you keep going.
No, I think you don't know how it's working. I asked my head of the AI team, so how does this work? He's like, yeah, it's a black box. We feed it, and then out comes the result. I'm like, that's a great investment. We have no idea how this works, but that's, you should feel safe. No, but it's very robust, and I think compared to other vision inspection, we have really kept it apart. And from our brief history in the US, we also learned that the machine has to be super robust. So you can basically hit it with a forklift and it will still inspect the pallets, because that's the way it goes here, I would say. And the good part with using the AI is we have a 2D image. So we basically snap a regular photo. It's not a very high resolution photo, but we take the photo and then we snap this big picture, and then we use this area. If you hit it and then you call us, we can adjust so we can look in different parts of this picture. So it's not, I think when we look at our maintenance department, there may be 9.2% over the air fix. So you don't need to go out on site, you can fix it over the air.
So I'll add a few more thoughts in here real quick. I want you to think about what this means for the industry potentially. All of you that are in pallet recycling and you buy a mixed load, most of the time you have no idea what you're getting. And you're relying on a guy inspecting those pallets as they enter your system, and maybe that guy's been there 3 weeks, maybe you're lucky and he's been there 6 months, but it's a pretty high turnover job, right? And you're constantly retraining that guy. And then you're relying on the people at the repair benches to do the right repairs, and the decision-making process is in the hands of people that may or may not have the best education on how to do that. And this takes the guesswork out of it, and I'm going to talk about 2 different arenas where this machine can be used. As we further step down the path of automation for pallet repair, I said earlier, it starts with knowing what you're getting, knowing what you've got, and analyzing what's there. And as that pallet goes to a repairman, think future state, we will have the ability to send images directly to the table. He'll see a pallet pop up, it'll come out onto his table, and he knows exactly what components need changed. He tears them off and puts new ones on. Once we get to that point, if we can solve that, then we can automate the removal of those boards and putting new boards back on. And that may or may not be happening already in a CHEP plant, but we're working on it. There's another industry that I think everybody needs to think about. You, as pallet companies, have pallet quality issues, and so do your customers. Anybody that processes pallets within their facility knows that pallet quality is an issue. And to solve the labor problem that we have in the US, nobody is raising your kids to say, hurry up and grow up so you can be an order picker in my distribution center. Nobody's saying that. These are undesirable jobs. So they're automating their warehouses. And they're spending hundreds of millions of dollars at single locations, which means these companies are spending billions of dollars on automating their processes. And who can tell me what the #1 cause of downtime in a distribution center ASR system is? Pallet quality. Pallets causing jams in the system. So you can use this to improve your pallet repair operations and your pallet sorting, and you're collecting data so you know exactly what you're getting, but it can also be used to solve your customer's biggest problem in their automated distribution centers. Think about what that means for your industry. Keep going.
I want to jump to the next slide, I think. Talk about other things. Yeah, this is, I chose a whitewood pallet here. So whitewood. So this is a GMA pallet. We basically check everything. And everything you can check, we can check, and then we measure it in a fraction of a second. So it takes the longest time is doing the analysis, and then we say, okay, so this is a stringer, and then we can measure the stringer. So in this case, we count the stringers, and we basically leave the decision to you. Because I had this issue with a 99.8% fails. Now I say, okay, here's 1, 2, 3, 4, 5, 6, 7, 8 stringers. I will tell you how many stringers do you allow, how many stringers per zone, how many repairs, and then I would leave that decision power to you to set it up. And you can say, okay, so an A grade pallet has no repairs, a B grade has 4 repairs, and a C grade has 15 repairs. I actually don't really care what you do with this information, but I have to give you the decision power, because otherwise I don't know what you really want to get out of it, and I think everyone is basically treating this information a little bit differently. But we check everything. We have different tolerances for edge material loss, because that's more sensitive. We have different criteria for height, for skewness, cracks, component alignment, nail protrusion. Yeah, we do block analysis, logo analysis. The same for the bottom deck boards. We can see rotated blocks, we can see stringer cracks, staples and stringers. Basically everything that you can see, we can see. And this is a very bad image, but it says logo quality low. So this is a Euro pallet with half of the logos gone, and we can still say, okay, this is an HT logo. And you can choose to fail this pallet for a number of different reasons. Like the material is missing, there's nails showing, or because the logo quality is low. But you can choose by yourself. So back to my big problem with the rejects. So we created a recipe handling. So in this case, when we run it out here, when the pallets go through, you're going to stand by the machine, because that already happens. But it was a good pallet, why did it fail? And then we have parameters, which is now set up for the GNA pallets and for the chef pallets. Where you say, okay, so the first board can be maximum 2 inches from the start of the pallet. The board length has to be 39 inches to maximum 41. It has to be at least 4 inches wide and 8 inches at the max. And we can change this. So if we run pallets, and I set this to 800, everything would fail. I set it to 2, everything would pass. But you can control this, and as you can see, the leading board edge material loss. So if there's material loss on the front end of the pallet, you can have different tolerances than on the back end of the leading board. You can move from the middle boards, because that's not as important as far as I understand. We count the middle boards for the bottom. Because sometimes there's 5 bottom boards and they're all in one space because they're super tiny. And then if we just count the boards, we will say this is a great pallet. We have to zone it and say in this zone it has to be at least 3 boards. In this zone it has to be 2. The same setup. So we have the power, the key to the Ferrari, we give it to Fred. Hopefully you will not drive off the road. But this is a waterfall model. So we set it up as so we check for the A grade pallet. And if it doesn't fit the A grade criteria, we check for the B grade. And if it doesn't fit the B grade, we go to the C grade. And then you can keep going. I think I told the morning team that the most I've seen in Sweden is 17 different criteria for one Euro pallet. And that's really, really hard to keep track of. Because it always goes somewhere you didn't think it would go. Oh my God, why did it go here? Because it's a lot of, it's 86 different criteria for each of these 17. It's easy to get drunk with power. Yeah, this is the resolution. So as I said, it's not a huge resolution. It's basically a regular camera, but this is the close-up view. And what we do with this information is we snap an image of the top side. And I use this image because you can see it's been repaired because there are nails in the second board where there should be no nails. And then we push it into the AI, and out comes the result. So we say, okay, this pallet, you can see the pallet image to the right, and this is what the AI interprets. We say, okay, here is material loss, the red parts. The blue are cracks. You can see that there are cracks which are not nailed, because you can check if there's a nail on each side of the crack if you want to pass that one, because then that's not as important as a unnailed crack. You can see the information about the boards, how far they are from the edge, how far to the next board. This is in millimeters conversion. But you can say that the second board has to be at least 3 inches. And then if it's not, we can fail it. These are the nails. So we find all the nails. We can check which nails are protruding and how much. Down to approximately 2 millimeters, so 3 millimeters. That's fine. I don't know, inch system, 3 millimeters.
How many of you have ever had a quality problem at your customer where your nails sticking up out of the pallet are damaging their product? You ever heard that? Quite a few hands raising. This finds those.
And then we do the same now out here for the chef pallets. So this is the chef pallet to the right. And then we find the boards, we find the materials on the edge, find the crack, but this crack is nailed because there's nails on both sides of it in the end. So this one is not as important, according to this specific. So it's a hugely accurate system, and our biggest problem is usually when we install it, you set the tolerances way too tight, and then everything fails, and then you're going to be severely unhappy, and then we have to work with you. So we spend a lot of time working through it. This is what we do. Don't set the tolerance to 48 inches. Have it 47 to 49, because that's actually where it's going to be. It's never going to be 48.
There's something that we find in the automation world, not in the pallet world, but think automotive, for example. Very tight tolerances, parts that should all be the same. If we take a manual process and we automate it, every time we find where they were having quality problems that they didn't even know about. And maybe it's quality in their assembly process, or maybe it's the quality that they're getting from suppliers. They thought they were good parts. Manual assembly didn't catch it. The automation systems always catch it. You're going to have the same thing when it comes to pallet quality. There are standards out there, or if some of you maybe do CHEP pallet repair, they have their standard that changes with the wind, depending on which guy you ask, and depending on how much customer they demand they have at any given time. This keeps everybody honest and everybody on the same page with the parameters that you enter into the system.
So it's as honest as you're going to be, right? Right. So we do the same for blocks. I thought I would show you. This is a CHEP block from Pallet out here. And then what we do is we build a model about this in 3D from the AI. And then we say, okay, so this is material loss that is classified as large. But we collect this data and then we build it like a 3D model. And then we can let the customer then determine if you're going to fail this block or pass it. And it also works, of course, for the liver block in there. The liver block in this one is way too tiny. But the good part with this is a lot of data, and we save all this data. So what you can do is you can set up like a batch for incoming goods. Okay, this is customer X sending me 500 pallets. You start a new batch, run the pallets through. You will get a very detailed report regarding which types of pallets, what was the defect, how many were good, how many were bad, how many were A grades, how many were C grades. Then you can go to the customer and say, this is what you actually sent me. And you can also use this on the outside. When you send the pallets away, you have very specific customers that need a very specific pallet. You can run the pallet through. And it's you have complained, this is the 500 pallet I sent you. Here's the report, because I have run them and they have no defects. So there's a lot of data associated with this, and that's basically what we speak about today. We started out speaking about pallet problems, and now it's all about the data. Because we can say also the good data. How wide are your average second boards? How many nails are average on the third board of the pallet that you run? So all this data can be collected and then shipped into other systems and integrated with your BI.
So, thank you, Stefan. For the next portion, we're going to have a panel discussion. Stefan will be part of that. Fred Brudevine from Niagara Pallet, whose equipment you'll see on display in our building, and Rick Van Yperen from Exigen ERP. And the reason I've got these guys, I want you to hear from them. You'll see Fred's line on our floor. It's using IVAS's technology, to my knowledge, for the first time in a whitewood sort and repair process, whitewood pallet. Fred, some people could say this is unproven technology, it's risky, and you just spent a pile of money on it. Why? What's your vision?
We need to, as an industry, start looking at the technology that is in existence and using it to couple and harness it to improve what we're doing. As you get farther away from the Mexican border, labor gets more and more expensive and more difficult to obtain. In Canadian dollars, we're $21 an hour to get people into our shop, about $17 US just for a laborer. And we're inconsistent. We're struggling to get good quality people that can make good decisions for us. And the challenge that we have is that as we add people to our organization, as we add capacity to be more people, we're giving more and more people the opportunity to make decisions on our behalf in regards to the pallets that we got coming in, if they're good, if they're not good, if we repair them, how we repair them, how much repair we do to them, and what they turn into once we repair them. There's a lot of value in that proposition, and I believe that the pallets that I have coming in my shop, I can get more good pallets out of it, I can get more money for the pallets coming into my shop because I can produce higher quality pallets because my guys will have to repair pallets to higher sale value items, and I probably have pallets that we're sending to our teardown and our shredder that I can repair because my guys didn't identify that as the right size pallet. And all of those challenges is what's driving me. The other side is as this technology develops, our customers, big distribution centers, are going to start using this technology, and we're going to start sorting the pallets that we get from their facilities. They're going to take out all the good pallets. Once they see that this technology is available, somebody in their operations system figures that out. You know, we're getting pallets from Amazon or Walmart or Home Depot or wherever we're getting them from. Let's just say that for argument's sake, 20% of the pallets are good to go and we're getting them into our facility and they don't take any effort. They're going to keep those 20%. They're either going to reuse them internally, they're going to ship them back to a vendor, and we're not going to get them for $2 and sell them back for $6. We're going to not get those good to go pallets, and we're just going to get pallets that we need to repair for $2 a piece. The other thing is that I've got some people that supply me with pallets, and I shouldn't be paying them for the pallets that they're giving me, or I should pay them less or more depending on the pallets that they give me. So I can't identify the source of pallets that gives me all the good to go pallets that I'm only paying $2 for, or I can't identify the source that gives me all those really junky number 2s that keep getting rejected because they just suck and they got 5 repairs each. A massive amount of my repair time. And when I can dial into that information, coupling the inspection technology with the ERP system, I can now make smarter decisions for our business, and I can tell the guy that's producing junky number 2s that I'm only going to pay him $1 or $1.50, and the guy that's giving me good to go number 1s by the truckload that don't need repair, I can give him $5 or whatever the scenario is. You guys, every one of our businesses is different, but every one of our businesses is the same in that regard.
So what would you say to the guy that says, you just spent $2.5 million on that line, I can buy a repair table for $2,500 and forklift the pallets to them and have them repair it?
I think you said it this morning. I got to write that line down.
It's self-serving, but I'm going to say it anyway. One of our customers a couple of years ago, we had an open house event like this at his place, and he made the comment, he said, Alliance equipment has a price, but it will cost you nothing. It makes you money. And we had estimated on the system that he put in, his payback would be 2 years. After he had ran it for not quite a year, he called me and he said, you made a mistake on your payback calculator. And I cringed. What's he going to say? He said, you told me it would take 2 years. It took 8 months.
I'm not expecting an 8-month payback on this system. If I do it, I'll let you know. I do expect that we have some challenges. There's sort of 3 ways that we can operate this system, because you have a lot of experience with sort and repair lines, so this thing can operate independent of any of the technology that we're stacking on it. It can operate with my operators telling the system in our ERP system what we're receiving, who we're receiving it from, and then we can go fully automated with IDASYS, which we're planning to do, and that's what you see on the shop floor here. IDASYS telling the system what we're receiving, what it's grading out to, and eventually we're going to tell the operators what they need to repair those pallets to as well.
So Rick, I'm going to shift gears and go to you for a second. Just give me an overview of who you are and what your company does.
Yeah, so we're a ERP provider from Canada, and basically develop ERP systems for any manufacturing company. So we have a lot of growers, we have a lot of companies in the green industry for vegetables. We also have steel industry, so we have like steel industry providing to automotive again. And basically, we've been in operation for 20 years, and now we're partnering with Fred to bring the future to the pallet industry.
What makes your software different and or better than other ERP systems that are out there, from your perspective?
So from my perspective, it is better because the way software systems are commonly built is they first start with a list of requirements, perhaps for an industry or for a business in general, and then those requirements are coded directly into the software system. And so what ends up happening is you end up with a software system that's completely rigid. It is basically coded directly into it. And so when you call to get a change, for example, they're going to be very nervous to make that change because it's going to affect their entire customer base, and it was coded rigidly into that system. So it's a big disruptive change. When we design a software system, and we're not the only ones doing this, but when we design it, the overarching requirement is that it just molds to your organization and can operate completely dependently of where it's installed. So if you make changes to yours, it doesn't affect Fred. So now you can actually call and get a change. So that's basically how our software system is different. If you understand it in the marketplace, the software systems that are the cheapest are the ones that are just coded directly, specifically for an industry, and they probably have a bunch of functionality. On the other end, the most expensive, you'd have like SAP and Microsoft, and of course, they'd be able to do it, they'd be able to make great stuff happen, but it'd be a big expense. We're somewhere in the middle. So we're not as cheap, but we're also trying to deliver really cost-effective solutions to our clients, give them the best of what they need from those bigger systems without the price tag.
So various times in this talk, we've talked about data. Fred mentioned it, Stefan mentioned it, I believe I mentioned it. We hear the term Industry 4.0. Tell us a little bit about your thoughts on that.
So because our software system is designed to conform around unique processes that our clients come up with, it is by default ready for Industry 4.0. And you might wonder, well, why is that so important? It's because with Industry 4.0, you can take your company from a company that is essentially a hunter-gatherer of technology and to something completely different. In the hunter-gatherer model, you have your company, and then you go look out at the marketplace at perhaps it's equipment, it's software, and you decide, maybe I can pull this in and I can utilize this in my organization. When you change your mindset with Industry 4.0, what you basically do is you don't even look at the marketplace at first. You first decide, you engineer a business that's going to be successful for you, for your needs, for your unique requirements. You first come up with a vision for your organization, and then you start to source equipment, software that's actually going to deliver on your vision. I was talking to Fred this morning on the way in, and I asked him how much he had known about Industry 4.0, and he said, yeah, I've heard about it. But yet, he is Industry 4.0 personified. He goes, this is what I need. This is what I need to have happen. And so it's a mindset shift. It's a shift of your mindset that changes, and you basically start building systems, and you start engaging with companies that can actually deliver on your vision. And we heard Doug say, we want people to dream. When you hear Doug say that, you know that their company, their culture, what they're doing here is they're trying to set you up to deliver on the solutions that your business needs.
So Fred, how in your mind, and we're about done, ready to wrap up here, but how in your mind do these two guys overall help you achieve your vision for where you want to take your company?
Big question there. I think the two sides that I see that are going to work together here is with Ibisys. They're going to identify what we're dealing with as far as the pallet or the platform, and they're going to identify the platform, and we're going to have a series of parameters that, based on that identification, it's going to enable us to make decisions, whether that's a repaired pallet, a pallet that does not need repair, tear down, shredder, whatever the parameters are. This morning the conversation went towards the dismantler, can I sort tear down by longboard or shortboard or different things like that. I think all of those things are possible, but that information needs to be processed by a software solution, and that's the ERP that we're going to get from Exogen, that's being rolled out as we speak onto our shop floor, and the information needs to be managed or manipulated or massaged by Exogen to give us the information and the decision making that we need. So I think it's very critical that they work together to accomplish what we're looking to accomplish.
Any questions for Ibisys regarding the Pallet AI or Fred or anybody else?
What's the cost of the Pallet AI system?
It depends.
I want Doug to use his earlier response.
What was my earlier response?
That's Fred. It doesn't cost anything to buy anything from Alliance because it pays for itself.
It has a price, but it costs you nothing.
There you go. That was the line.
Fred, what was the price?
I'm going to defer to Stefan.
Yeah,
You're selling it.
I think it has a lot of variables. How many pallet types do you have? What kind of speed do you have? What type of inspection you want to do? So it's hard, I would say, to give a exact answer. You have a lot of different pallet qualities, sizes. It's a wider machine because you want to run 60 by 60 inch pallets.
Yep.
So there's a lot of variances. So it's hard to give a straight answer to that question. It's very cheap.
I'll give you a starting point. It's $500,000 and up depending on options.
Exact same line, how much would that cost?
Fred, what'd you pay?
I told you I want to pay less than $2 million.
Are you talking the whole line, Curtis, or just the box?
The whole line.
2.5. I don't remember exactly.
Yeah, with the AI, I think we're.
Yeah.
How many pallets do we put through that training here?
We run 2 shifts. We run 80 hours a week. We want to put 2 million pallets through that system per year. We already have the robotic dismantler and the urban sawmill. We don't expect the robotic dismantler to run at capacity in that line because we also don't want to clog that thing up. But I figure 2 million pallets through there, repaired and or inspected. Good to go pallets are going to bypass the repair area, and I'm not sure if you're aware of that. There's a conveyor that discharges off just past the inspection, just before the repair cells. That's where our robotic dismantler will go. So all the tear down and scrap will go offline to the, not really offline, it will go to the tear down line before we get into the repair and good pallet stacking.
So we didn't have the floor space to set up his line in total as it will be in his building. I wanted to, but my team told me we can't get it done. But as he shared, right after the AI box, there's a spur that will go to the robotic dismantler, which will automatically feed onto their urban sawmill. Fred mentioned earlier, his vision is to have where he unloads the pallets, puts them on the line, and they don't come off, they're not handled again until they're done. His line will truly give him that.
Will that all be in one building?
Yes, the stackers will be in, we've got 2 sections to our building, so they'll be in the second section of our building, but they'll all be in one building altogether.
How big is your building?
100 by 200.
Another question.
So can the AI system do crack detection on runners or just,
Yeah.
I know you guys said
I can
blocks.
show you if you come over there. So
That'd be great.
And if there's people that are sticking around for the afternoon session, feel free to go over there and ask questions like that, and we're willing to take a pallet. You can look at it, see what you see with the naked eye, then we'll run it through the machine and show you what the machine found, and I think you'll be pretty impressed with what it sees.
Fred, is AI telling the pallet to go to the robot?
Which robot?
You're dismantling.
The AI is going to give parameters that'll tell us if that pallet is going to be good to go or if it's repair, and if it doesn't meet those parameters, it'll go kicked offline to the dismantling.
Or it goes through AI and then.
Yeah, it's going to get inspected, and the AI is going to make the decision. So we're going to take the human decision-making factors out of, is this a tear down? Is it a repair? Is it good to go? And then the next level will be, these components need to be repaired or replaced in order to meet the quality expectations that we have. So, right now you're training guys to repair pallets specifically for, I want that to be an A grade, I want it to be a B grade, but the guy, he takes the path of least resistance and he takes your A grade and he puts a plug in it instead of plating it, or whatever your parameters are, or he doesn't put a 6-inch lead on the bottom, and all of a sudden your A grades turn into B grades. You have the ability to start controlling some of those QC processes with the AI, because now you can tell your operator, you got to replace that component, and maybe you replace a 4-inch with a 6-inch, or whatever the parameters are. Imagine them. The variables are endless. But I can control the quality coming out of my repair guy, where I don't do that right now because my guy makes the decision. I've got to have a second set of eyes on it. The inspection technology has the ability to start creating higher quality pallets because my guy is forced to fix to a certain quality level.
So Don, to add more detail, sorry, just a moment, to add more detail, as the pallet is scanned, the AI system finds everything on it, and then we go through what we call kind of a waterfall decision matrix. And if you say, okay, we scanned a 4840, this is what I want for an A grade, do we meet all the criteria for an A grade? If one of them fails, it automatically starts scanning, do we meet all the criteria for a B grade? And then you can set those parameters to be whatever you or your customer base is demanding. And if it doesn't meet any of those standards, kick it off to the dismantler or to the grinder or whatever you do with them.
Yep.
Right.
So, I understand the AI system will tell your repairman what to repair. And it may be the AI system is saying, hey, put a 6-inch bottom B-board on here. But your repairman puts a 3.5 inch on it.
Different repairman.
Fire your repairman. Or,
I think you're bringing up a valid point. So we're not having inspection coming out of the system, so our employees will need to do what the system tells them to do. At this point, we're not going to have that out of the gate. That's one of our criteria that we want to get to in the future. But I do believe it's a parameter that is going to become valuable in our industry, because if you're selling a B grade, or if you're not selling B grades right now because you don't have a home, or you're selling B grades for $5 and you're selling A grades for $9, if your guy has the ability to make a decision, influence that variable in value, you need to empower him to make value decisions to get more value out of the same stream of pallets. Because at the end of the day, the pallets coming into my facility aren't changing. I need to make different decisions to get more value out of those pallets.
That pallet's going to go to that stacker, regardless, the AI identified stacker, regardless of what that repairman is.
Right now it will, yes.
so there are some plants within the US that have vision inspection at the beginning of the line and again at the end to combat that issue. Another alternative is if a whole bunch of you got together and funded our R&D program, we'll get to automated repair a lot faster. And you can just skip over that guy.
I'm setting up a GoFundMe tonight.
Yes.
So we have an urban sawmill, and we run a long board setup and a short board setup. Frequently, we have two short board. Just too much, so we grind them. And the Pallet AI system be set up to tell us what boards we are getting out of the pallets that are being sent to the dismantler. Because the USO gives me all kinds of data by size, by hour, by shift. Does Pallet AI tell me what boards I'm getting? That way I can go back to the source of my scrap and say, well, 40% was short board, I'm not going to pay for it. Whereas someone that's giving me 90% long board, that's the one I want to keep.
Right. Right now, no. But I can certainly see that as a possibility. And I can't promise you a timeline on that. But we are measuring the pallets. We know the board dimensions.
What's a short board? I'm sorry.
It's under 40. Well, for me, it's under 40 because that's less value. Everything 40 and above has more value, so I call it small board.
Okay, so but you can measure the length of each board and of which source is coming. And so you want to send those. So if they're shorter, you don't want them to go to the dismantler. Yeah, but so what we're going to start off with you, Fred, is we're going to measure the dimensions, and we can measure each board. And you're going to classify them into size initially. So you have the same setup, I think.
Yeah.
So you have a 4840, and that means 47.5 to 48.5 or whatever. And if it meets those criteria, it's going to go straight. If it's less, it's going to go to the grinder, but if it's way less, it's going to go to the grinder. And if it's somewhere in between, it's going to go to the dismantler. So you can control the flow either way you want.
I think those parameters already exist in how you establish the criteria. You just have to figure it out in your plant how to get the short board into the grinder and the long board into the dismantler. And those parameters can exist in this system. You just have, let's just say you have two kickoffs, for one for short board, one for long board, and then tally those, what goes to those kickoffs. I think there's way there. It's just a matter of these guys, your teams being intelligent and providing a solution.
So hearing your explanation a little further, I think it would actually be fairly simple to get to that point. we are already gathering all that data. It's just a matter of making the decision of what we're doing with that data. But I think the answer is yes. Sooner rather than later, I think we can get there.